This is the NU32 development board. The primary purpose of this board is to break out the pins of the PIC32, so our 100-pin PIC32 is sitting right here, to break out those pins to these 2 rows of pins on this board that attach now to the protoboard, so we can now stick wires into the protoboard and therefore attach to the pins of the PIC32. So that's the main purpose of the board. But to make the PIC32 work, we also have to have a little more electronics on board, so we're going to go over some of that right now. First of all, over here on this side, you can see that we have a 6-volt input jack. So there you're going to plug in your 6-volt power supply, or if you prefer, batteries. And so the voltage will come in, and then on board we have 2 regulators. We have a 5-volt regulator and a 3.3-volt regulator. And the purpose of those is to step down the voltage from the 6 volts to 5 volts and 3.3. 3.3 volts is what's used to power the PIC32, but often you want to have 5 volts available because other circuits might need it. So by having this NU32 board sitting on these protoboards, what we do is we actually break out the 6 volts, the 5 volts, the 3.3 volts, and ground onto these 4 rails here. So this rail right here is the ground rail. The next one down is the 3.3 volts. Next one down is 5 volts, and the next one down is the input voltage, which in this case is 6 volts. So now you can connect your wires to any of these rails here and get power to power your external circuits. In addition to the 6-volt input here, we have a mini USB port, and this is where you attach your cable from the NU32 to your laptop, and this allows you to talk back and forth. The talking back and forth, your computer actually speaks USB, but you have installed on your laptop something called the FTDI Virtual COM Port driver software. And what that allows you to do is basically use your USB port to talk RS-232 to your PIC. And this is the chip here that controls that communication. So by plugging in your USB cable into your laptop, you now have 2 communication ports available. And we're going to use one of those ports to program the PIC32, to put new programs on there using what's called a bootloader. And we're going to use the other channel so that we can talk back and forth with the PIC while the program is running. Okay. We also have a power switch over here. So when you switch it on, a red light will come on showing you that it's powered and ready to run. This is the PIC32, and this is the main actor here. We also have some capacitors and resistors and other things on there that the PIC32 needs for proper wiring. We've also got 2 LEDs here called LED1 and LED2, and those are just so you have some simple feedback. You can turn those lights on and off, flash them, and make sure that your programs are working. So even without connecting anything else to the PIC, you can get some output from it. And there's also 2 buttons. One's a reset button, one's a user button. When you press this reset button, the power is taken away from the PIC, it powers off, and when you let go, it comes back on. The user button is here for your own input. So now if you write a program and you want to take some simple input without connecting anything else to the NU32, you can at least use the user button for digital single bit input. The last thing that we have on here is the USB to external device jack. And this is to allow you to plug in a USB cable to some other device, maybe a cell phone, for example.